the student, as in this lecture series of telemetry systems, we started with the telemetry definition, then the classification of the system, then the various part of the telemetry block diagrams. Till now we understand one point, that telemetry is tele plus meter, means the measurement at distant location, means if you have any arrangement at a far place or a remote place, you have to take the measurement there. That measurement is going to be converted into the electrical signal, then transmitted towards the next end, and there you are going to use that transmission or the received signal as per your requirement for the recording purpose, for the analysis purpose, for the calculation purpose, for the recording purpose. As per that telemetry definition, we have various kind of classification also. That classification was wired or wireless telemetry system, analog or digital telemetry system, or electrical or non-electrical telemetry system. In the previous lectures, we understand about the various electrical telemetry system. In electrical telemetry systems, we concentrate on voltage and current telemetry system, frequency and pulse telemetry system. Voltage and current telemetry system are basically related with analog, frequency and pulse are basically connected with digital telemetry. Whether voltage and current was for short distance measurement, whether the frequency and pulse are used for medium and long distance. That was also wired telemetry system of voltage and current, whether the frequency and pulse telemetry systems are wireless telemetry system. Now you can understand one point very clearly. In these both kind of techniques, the output is always in the form of electrical energy, but this is not the only part of telemetry systems. Also there are some kind of telemetry system exist in which electrical conversion is not required, and the complete transmission is conducted according to the non-electrical quantity, such as mechanical displacement or pressure of the air or the flow of the fluid. So as per that, in today's content we are going to discuss about the non-electrical telemetry. First of all, you can understand one point very clearly. This non-electrical telemetry systems are not applicable for long or medium distances. Why? This question is arise. Why? Basically, for the non-electrical telemetry, you always have to arrange some arrangements of various mechanical parts, that various mechanical parts are maybe some kind of pulleys, maybe some kind of gear, these gears, or some kind of shaft. These all arrangement are going to be used in this particular part. So, starting from the mechanical telemetry system, what you are doing? You are basically using gears, links, levers, chains, pulleys, shaft, that all are connected in cascade. It means at the transmitter part you are having gears, links, levers, chains, pulleys, that all are connected such that here is a platform, this is the platform, that platform is basically platform of a weighting machine. The load is applied on this platform. This platform is connected with these levers and the shaft. What is happening whenever you are applying the load on this particular platform? This platform going to change its position. That change in position is applied through this levers to this particular transmitting shaft. That transmitting shaft is going to convert this load into displacement. That displacement is going towards this pointer part, and pointer part is going to point out the exact weight as per the calibration of this weighting machine. So, you can easily understand this complete structure of a telemetry system. You are taking the remote measurement, the parameter is here actually, you are taking the account here, means this is the transmitter part, this is the receiver part. This extension lever is basically channel, and you can see that between transmitter and receiver there is a physical channel. That is why it is a wired telemetry system also. No any type of electrical conversion is there. It means it is a non-electrical telemetry system, or it is completely mechanical. It means you are using a dial pointer indication system using a transfer mechanism. This is the dial pointer mechanism. That dial pointer is connected through the extension lever to the weighting part. So, this is the mechanical telemetry system. Now, second part, pneumatic telemetry system. Sometimes you have to change the particular physical quantity in form of air pressure, and whenever air pressure part is coming into the picture, you are going to use compressed air. It means in a pneumatic telemetry system, compressed air is used to communicate the value of measured quantity from one location to another. Now, here you are using a compressed air, it means a compressor is required. Compressor is required. And what is a compressor? Basically, compressor is a unit which is creating air on high pressure or as per the requirement. It means in the pneumatic telemetry system, you are going to use those kind of transducers or sensors which can measure the air pressure, and that kind of particular Transducers are bellows or balloons or diaphragm or Burden tube. These kind of transducer are going to be used in pneumatic telemetry system. It means in this particular diagram you can see here it is a arrangement of a tank, liquid tank. This is a liquid tank, some kind of water or liquid is there, and this complete unit is going to measure the change in level of particular water. What you are doing here? You are providing a floater. Floater is made of some light material which float on the fluid surface, and that floater is connected with pivot lever or float arm pivot to this push rod, That push rod is placed in this cylindrical encapsulation, and that push rod is connected with the stroke lever. Here you can see that this is the push rod, it is connected with the stroke lever. Here we have 4 balloons or 4 bellows that are A, B, C, D. 2 balloons A and B are placed at transmitting part, 2 balloons C and D placed on receiving part, and for the channel we are using pneumatic lines. These pneumatic lines are basically pressure pipes in which air is flowing on high pressure. Now what is happening? By using a compressor, we made a compressed air environment in this pneumatic lines. These pneumatic lines are connected with these particular balloons. When the level of the water will increase or decrease, this push rod will also make some kind of displacement. That displacement is going toward these bellows through this stroke lever, means this stroke lever will expand or contract these balloons A and B, and when these A and B balloons will expand or contract because the change in the because the change in the position of the push rod through the stroke lever, you can see that this stroke lever is connected here, interface disc. This interface disc is going to change the bellows condition, whether it is going to expand or whether it is going to contract. And when this expansion or contraction take place, what will happen? Actually the pressure in this pneumatic line will change. If these bellows expand due to this stroke lever or change in the surface, the pressure will decrease in the pneumatic line, or if it will contract, the pressure will increase. That change in pressure will be transferred through these pneumatic lines to these C and D balloons. These balloons are connected through a link and a pointer is placed on that link. Also there is a meter at a distance. So basically what will happen, as far as this pressure will increase or decrease in this pneumatic line, the condition of these D and C and D balloons will also change. there is a expansion or contraction. It means if A and B balloons are expanding, they will contracting, if they are contracting, they will expanding, and due to that, that link will work and there is a change in the position of the pointer. At that change in pointer will shows on the meter at a distance. More specifically, you can understand this point directly, that there are 4 bellows element A and B transmitting with stroke levers and the interface disc D, C and D from the receiving and display block and along links. Also, the 2 blocks are connected by pneumatic lines with the float rising or falling, the push rod move up pressing bellows element B or expanding it. So, increase pressure in line 1 or 2 will expanding element D or C at the receiving end. This particular cylindrical tube is known as fulcrum pipe. So, in the pneumatic telemetry system, you understand one point very clearly, that the change in pressure is the main component which is going to help you for the change in process. Then the point next, here you are converting the complete part into the pneumatic lines, and there is a drawback with the compressed air, that any kind of small leakage will destroy complete system, or also airtight condition is required for this complete system. This will increase the maintenance of pneumatic system, and as air compression and expansion have some saturation limits, that is why sudden changes cannot be observed directly, or the minor changes cannot be observed. So, for the checking of minor changes, the complete system is going towards the hydraulic telemetry system. In hydraulic telemetry system, what is going to be happen, that in hydraulic telemetry system you are going to use a fluid. How it is, how this fluid is going to be selected? So, you can understand by this particular one parameter, viscosity. The viscosity of fluid is a major parameter in hydraulic telemetry systems. Another points are also there, but viscosity is also a very specific parameter for this. In hydraulic telemetry system, there is a arrangement of reservoir. That reservoir is basically filled with that high viscosity fluid. That reservoir is connected with the all pipes or all the lines. Here these are various lines. A hand pump is placed here. That hand pump is used to give that liquid supply in the complete these lines. In this particular arrangement, you can see that this is the actuating cylinder. What is going to happen? You are applying the physical quantity change in the form of pressure, load, weight or displacement on this particular lever of the actuating cylinder. As per the change in physical quantity, this lever will change its position, that will change the position of the shaft in the cylinder. As per this movement of the shaft in the actuating cylinder, you can see that the fluid will make pressure or increase in the increasing form or on the decreasing form. Means you can see that in this complete hydraulic telemetry system part, you have three conditions in the pipes. First one is suction, that pink part is showing the suction part. Red part, that is showing the high pressure part, and green part, that is showing the return part of the fluid actually. When you are going to apply hand pump, that is actually giving the fluid to this complete system. Then what is happening here, a actuating cylinder is working, which is going to take the measurement of physical changes, and as per the movement of actuating cylinder, piston, that is the piston, that piston will increase or decrease the fluid pressure. You can see that here, that complete changes is here. For the system safety, there is a pressure relief valve. Here one way check valve is there, because that one way check valve ensure that fluid will be flow in the right direction. Here is a motor driven pump, and here is a filter, or this is the metering part. At this particular portion, the calibration or measuring is done. So you can see that due to this high viscosity fluids that is going to be used in this hydraulic telemetry system, you can easily understand that you are taking account of physical changes of minute magnitude. If there is very minor magnitude changes in the system, it means you are going to apply this complete system. So, in the hydraulic telemetry system, basically it is used for measuring minor changes also. Whether in the pneumatic you are not able to check the minor changes. So, in the non-electrical telemetry system, you can easily understand one point, that here you are either using the link, gears, shaft, chain, pulley drives to measure the particular physical quantity and sending it towards the distant end. Either you are using the compressed air through a compressor, or you are using a high viscosity fluid for the measurement purpose. But one thing is common in all these three techniques, that there is not any type of electrical signal for measurement. That is why these are non-electrical telemetry systems. So, advantages and disadvantages. Basically, these all systems are safe and explosion proof. Explosion proof is why? You can see that you are using a one way check valve. Also, in the bellows you are using here some kind of interfacing disc and the valves arrangement for the pressure measurement, which is making it basically explosion proof. Then unaffected by the electrical power failures, because there is not any type of electrical component, or there is not any type of electrical arrangement or electrical power supply is required for the operation of the non-electrical telemetry system. You does not require any electrical power, and when electrical power is not required, means failure is also not going to affect the system. Then actuators and control valves. Actuators are basically those devices which are working as per the changes or giving the mechanical changes to the system. Control valves are maintaining the pressure, either in the case of a compressed air or in the fluid. and they are directly operated through physical changes without requiring any conversion. You can understand here one point, in electrical telemetry system you are using the transducer to convert physical change into the electrical quantity. Then signal conditioning unit is converting that electrical quantity into electrical signal, and then that electrical signal is communicated from transmitter to receiver. But in the non electrical systems you are not converting any physical quantity into the electrical signal, you are directly taking that physical quantity, either you are taking the pressure, you are directly applying that pressure in the system, and that pressure is going towards the transmitter to receiver through the pneumatic lines or the hydraulic pumps or hydraulic pipes. It means you understand there is not any type of conversion is required. That is why it is also, it will also applied give us a advantage over the electrical system. Also improved dynamic response and facilities for calibration and checking. In the electrical system you required some kind of specific arrangement for the calibration part, for the response part also, but in the non electrical telemetry that dynamic response and facilities for calibration will also improved by using this control valve or actuators. So, these all are the advantages of the non electrical telemetry system, but there are some disadvantages also. That first one, they are slow to respond because there are some physical changes, and that physical changes is going to be shown in the form of that particular response, and in that are sometimes they are quite slow, sometimes they are quite slow. Then also system is not suitable for long distances, that I already told you in the starting of this lecture, that for the long distance transmission or for the long distance measurement they are not applicable, because for that you required bulky arrangements of pneumatic lines or levers or shafts, which is not possible, and also the maintenance cost is also very high. So, basically in this lecture we understand about the non electrical telemetry system, and till now we completely know about the telemetry meaning, definition, and completely its classification. In the next lecture we are going to take a live example of telemetry system which is going to be used by the system, and that is called PLCC, power line carrier communication, widely applied in the power transmission and distribution units. So, till then, thank you.